Hey everyone. So this is going to cover section 1.3 from your textbook. And remember that we are in chapter 1, which is Introduction to Chemistry and the Scientific Method. And in section 1.3, we're looking at thinking like a scientist. So I think of all sections out of your entire textbook, this is probably the most important. If you can get this skill out of general chemistry, then you will really have a great life. How do you like that promise there? Really, it's important that we think like scientists in every single thing that we do. It really becomes vital because nowadays, one of the problems that we have in modern culture is that people don't think like scientists, and this is where people get into trouble. So, you guys use the scientific method more than you can possibly imagine. In your everyday lives, you probably already think very much like a scientist, but you really want to really run any claims that anybody makes on anything. I would run all claims that anybody makes through the framework of the scientific method. So I want to talk to you a little bit about the scientific method and the history of the scientific method. This is not covered in your textbook, but the scientific method, the scientific revolution, I should say, which culminated really in the founding of the Royal Society of London in 1660. It really was brought about by the works of this man here, who was Francis Bacon. And so Francis Bacon, unfortunately, never saw what he so hoped for. He never saw it in his lifetime. It didn't come until some 34 years later. But we can really credit him for the scientific method as the Royal Society practiced it and as we see it today. And for a lot of the philosophical underpinnings of the Royal Society's purpose, we can really thank Francis Bacon for this. So I want to give you a little bit of history on Francis Bacon. We had the Protestant Reformation that started in 1517. I think it was October 31st when Martin Luther nailed his 99 Theses on the chapel door at the Wittenberg Chapel. And what followed, the type of thinking that then followed with that, really generated much more scrutiny. People were really scrutinizing everything, the claims of everything with this Reformation. And what Martin Luther also really restored to the church and the cultural milieu while he was in Germany was the idea of the Adamic fall. So the degree by which man was just plain sinful was in some measure it was lost. And what the Protestant Reformation did was it put the Adamic fall back front and center. And one of the interesting things that Francis Bacon was fighting against, and you'll actually see in a minute, I looked up the history of the Royal Society, and there's really some cool history that's going to really affirm what I'm telling you now. But Francis Bacon was really a little soured about the power that Aristotle had in the academy at the time. And by that I mean the universities, Oxford, Cambridge, any of the universities that were in existence back during this time. He was really resentful of just how much authority anything that Aristotle said was given. And you had these brilliant scientists who were like, I don't know, Galileo and Copernicus, and they were looking up at the stars, and they were really seeing what appeared to be a heliocentric universe, not a geocentric universe where Earth was the center, but a heliocentric. And nobody would listen to the data and the observations that these men were making because they were all appealing to what Aristotle had said over 1,000 years prior. And Francis Bacon was a little soured about that because his idea was that, for one thing, Aristotle was a pagan. And another thing is that Francis Bacon said we need to grow skeptical of anyone who makes claims that are truth just because of authority. And so Francis Bacon, being keenly aware of the impact of the Adamic fall, this is kind of interesting. Martin Luther and his contemporaries, they believed that Adam, prelapsarian Adam, had the capacity to gaze into space and he had telescopic vision, so he could see the very edges of the universe. And they believed that Adam also had the ability, like or I should say, X-ray vision, so that when God was presenting the animals to Adam, that Adam could look at the way their bones were structured and the attachments of the muscles, and that Adam, just in looking at the animals, he could get a very good vibe for what the essence of the animal was, and he named the animals accordingly. And when sin came in, not only did Adam become a very immoral being, but Adam also went from being just this unbelievable genius to being an imbecile. And this was their belief. They believed that mankind became significantly cognitively impaired. And for Francis Bacon, he is looking at Aristotle and saying, this is a representative of mankind. He is cognitively impaired. We need to really be skeptical of the claims that he is making. And Francis Bacon actually identified 4 idols of the mind. And it was really what he was identifying were presuppositional frameworks, that biases that people carry with them when they are actually pontificating about the world. Francis Bacon didn't want any of that. He said humanity is so sinful that we just can't rely on reason alone. We need to look at evidence. And this actually gave way to a codified scientific method. So, this is actually really key. We could not have had a scientific revolution without first having a reformation. So after Francis Bacon, he wrote some really, really great books. I've read a couple of his books. Brilliant man. 34 years after he passes, founded in 1660, we have the Royal Society. And this was founded as what was called an invisible college of natural philosophers and physicians. Note that they don't mention the word scientists. And that's because there were no scientists at this time. The term scientist wasn't even really in their lexicon at this point. It wouldn't really enter in until probably about 150 years later. So we call them natural philosophers. If you look at Isaac Newton or Robert Hooke or Blaise Pascal, we would call them natural philosophers, not scientists. I mean, today we call them scientists, but back then they were natural philosophers. So I don't know if you guys can see on the coat of arms there's a little statement underneath that. The motto, I don't even know how to say it. Is it nullius in verba? It means take nobody's word for it. And this was an expression of the fellows of the society to withstand the domination of authority and to verify all statements that are made about the natural world by an appeal to facts, listen to this, determined by experiment. So they weren't wanting pontifications. And it's kind of interesting, if we look at this motto, and if we look at it today in terms of how the term is being used today, follow the science. We heard, many of our leaders, I'm thinking of Anthony Fauci for one, saying follow the science. He was the science. And actually this objectively was not true. Anthony Fauci was an authoritarian. And the founders of the Royal Society would be turning over in their grave if they would have seen him coming along and saying, because I say it, it must be true. And what's interesting is a lot of the claims that Fauci had made early on, and I'm not saying this to be political, I'm looking at this purely from a standpoint of science. A lot of the claims that Fauci made early on, we are now seeing a lot of papers coming out in the literature absolutely debunking them. And we're actually even seeing that through the scientific method. We're realizing that these claims were not valid. So it's kind of interesting. Take nobody's word for it. This was the skepticism, not cynicism. This was the skepticism of the founders. They're saying we're not going to believe something because Aristotle said it. We are going to believe things about the natural world based upon an experimental process that proves that the thing you're saying is actually true. So the founding of the Royal Society really brings to us what is called, we now have a reification, or we now have the institution of science with the founding of it. So here is the scientific method. The scientific method, you see that the first step is to make observations. So as a scientist, they are going to observe certain things about nature or a natural system. Could be a metabolic pathway. It could be it could be weather patterns. It could be any number of things. So you're going to make observations, and from these observations, you're going to generate what's called a hypothesis. And a hypothesis is a testable statement. It doesn't have to be a question. A hypothesis can be a statement, but you have to be sure that this statement is something that is testable. That this statement, we can either say, yes, we found by our experiments that this statement is true, or no, our experiments show that this statement is false. That is what a hypothesis is. And then what you do after you formulate this hypothesis is you develop an experimental protocol. And the purpose of the experiments is either to test the veracity of the claims of the hypothesis, or to prove them whether they be true or whether they be false. And if your experiment shows that the hypothesis is true, well, guess what you're going to do in the world of science? You're going to perform many, many, many more experiments. And if many, many more experiments prove that your hypothesis is true, then we can start looking at a theory. So it takes a lot. Well, maybe it might not nowadays because we're doing a lot of junk science, but when we looked at science as it was instituted in 1660, these guys were really demanding rigorous experimentation. And that really, we have a crisis in that right now, because we're just seeing where this is not, we don't have the same methodological rigor today, which we really do need. So this shows, I already told you this, this outline of the scientific method shows how observations lead to the development of hypotheses and theories. And I already said this, if experiments prove a hypothesis false, a new hypothesis must be proposed. And the scientific method as we use it today is a completely different method of gaining knowledge of the natural world. We call it an epistemology. And epistemology is just a $3 word for saying a way of knowing. So the scientific method as a methodology for testing whether things that we see about the natural world, observations that we make or conclusions we make about the natural world are true or not. It's been a very powerful epistemology. And actually what this methodology led to was an absolute explosion in the world of science. It just, from 1660 on, an absolute explosion. I might add that prior to 1660, there really was not an occupation, a paid occupation of a scientist, because people just thought, oh, you're just a tinkerer. You're kind of a bum, you're a tinkerer. Well, when the Royal Society was founded, it reified science as a legitimate methodology. And then we started actually seeing occupations for scientists or natural philosophers. So this is going to lead into yet another video that I'm going to do. I'm going to continue with this idea, but I didn't want to give you guys a super long video on whether Darwin did use the scientific method in his writing of The Origin of Species by Means of Natural Selection. And this is a really great question to ask, because people will credit Darwin as being a great scientist, rock solid science. And the question is, oh, did he really use the scientific method when he was collecting his data? So we will explore that in still yet a different video. But for right now, you guys should be very familiar with this process. You guys should know the difference between scientific theories versus a hypothesis versus a law. You guys should really know the difference between all three of these terms. So I will see you guys in yet another video, and God bless.